we got up until 15. You completed 15. Obviously 16 onwards is what you're looking at. So remember, how many do you need to pass?
15.
Exactly. So if you can find 15, it doesn't matter where. So remember, it's multiple choice. So you can start with question 30 if you want to.
Yeah.
Alright, so I would be looking at each of these questions and I'd be saying, well, can I do that quickly? Yes or no? Is it easy? Yes or no? If it is, I would do it. Okay, if I'm like a little bit undecided, not too sure, then I would leave it and I would come back to it later on.
Yes.
Okay, because you've got 2 hours. So in the first hour, you should be finding 15 that you can do very easily and very simply using maybe the financial calculator or just simple mathematics in order to get the right answer. Okay, so we've obviously been just looking at it one by one, and we've got up until 15. So question 16 was the beginning of the time value of money. There's it. Alright, so 16 says, let's just put up the workings as well, and we can complete it as we go. Okay, so the key with time value of money is just identifying variables. That's it. So here you've got Joe borrowing that amount, 75202, from his brother to buy a boat. The interest rate is that, compounded half yearly. That's important because half yearly means N is times by 2. Okay, so PV would be the 75,202, and the rate I2 would be 11% divided by 2, which is 5.5%. Okay, then you've got he promises to repay the loan in 12 equal payments. Okay, so they've already told you there's 12 equal payments. So they've given you the number of payments. So N is just 12. Alright, and they tell you that the PMT is 8725,63. Considering the amortization schedule, the outstanding principal at the end of the second half year is. Okay, so we're looking at using amort. Okay, what is the principal? Yeah, principal after the second half year. Okay, obviously second half year means
of the 12 months.
No, not 12 months. We're looking at the second half year. Oh, okay, I get what you're saying. Okay, so you're saying 2 6-month periods, which is 12 months. Okay, that's fine. Yeah, so the second half year. So the first half year would be 1, and then the second would be 2. So it'll be the second T, basically. T2, in other words. If that makes sense. Okay. Right, so obviously the first thing I would want to do is I would want to get what the actual payment is using my normal function on the calculator. So I would insert this and I would solve for the PMT. That's what I would do, just to check if I'm right. So PMT equals, or to check if they're right, payment, PMT, brackets, the rate was 0.11 divided by 2, the N was 12, the PV was 75,202, and then I'm solving for it. Yeah, okay, so that's right. See, they've got the right payments. Okay, so you need all the variables in the calculator, right? Okay, so on your calculator, shift, master clear, reset. Okay, then let's put in 75202. 75202 is
the
PV. Okay, then 5.5 is I. 12 is N. Right, then what do? Compute for PMT. Compute PMT, and I can see it's correct.
Yeah.
Okay, then once I've done that, what do? On your calculator, you press amort.
Yeah.
Okay, I want the second payment, so second, enter. Scroll down, P2 must be 2, enter. And then scroll down, that's the balance, that's the principal. Okay, so yeah, it would be none of the above, so you were right.
No, I was talking about question. What I've done wrong with question 16 is I said 6 months instead of like 12 months.
Yeah, compounded half yearly.
Yeah.
And the loan is, there's 12 equal payments. So there's 12 payments. There's 12 payments every half year. Because that's it's the half year. So they're paying every, let's just see their payment. Yeah, see, he promises to repay the loan in 12 equal payments. Okay, so if there's 12 equal payments, there's 12 payments that are half yearly apart. So every year, every half year, he's going to pay 8,725. Okay.
Okay, so the future value will always be 0.
Yeah, because you're paying off the loan.
Because I'm paying, I don't know.
Yeah, so the answer that you get here is, so solve for principal. Principal was what? 4841, comma 94. Okay. Alright, so
do the amortization again, please.
Amortization as in?
Do it on the calculator again.
Yeah, so you first insert all the variables. So second function m clear everything. Okay, let's write that step down.
Yeah, that's what I know. And I know to immediately go to amortization.
Yeah, to get the payment, eh? Yeah. So 75202 PV.
Yes.
Okay, and then
12 for the n.
11 divided by 2 is 5.5 I. Okay, 12 n compute PMT.
Yes.
Okay, so is that right? Yes. Okay, now I need to look for what? The second half year. So amort, make P1 2 because that's what I'm looking at.
Okay.
Okay, and then scroll down, make P2 2 as well. See, now if I go up and down, look. Up and down, P is 2.
Okay.
Okay, then I have to scroll down and read the right answer.
Okay. Awesome.
Alright, next bit. Question 17. M takes out a 5-year loan to buy a car. So we know this is a loan again. Finance is 13% per year compounded monthly. So I-12 is 13% divided by 12. M can afford payments of that. So PMT equals 3412,96. She also has 25 for a deposit. Okay, so that's additional information. Additional info, 25,000 deposit. Okay, the price of the car. So they want to know how much the car is, and it's a 5-year loan. Okay, so obviously 5 years. 5 years times 12 months is 60 months.
Yes.
Right, and that's what you've got. You've got everything. So all I need to do here is solve for PV, and that's going to give me the loan amounts. Okay, because I've got those payments over that time period with that rate will give me this present value. Okay, so 0.13 divided by 12. N is 60. Payments, we need to put that in 3412,96. And if I solve for PV, I get that. Okay, if I round it off, it'll be, oh, well, I don't have to round it off because it's there. Okay, and then add.
Okay, my present value isn't the same.
13%, 5 years. Did you put the right payments? PMT, where's your PMT? Okay. Oh, did you solve for future value? Okay, redo. On the calculator, redo. Something went wrong. Okay, so then this plus 25,000 gives you 174,9996, option 1.
No, it's still not getting it.
Okay, what are you putting in? Try again. Second function, clear everything. Right, what's your N?
It's 60 months.
Okay, so 60 N. What's your I? 13, so type in 13. Divided by 12 equals Okay, that's your I. Okay, payment. Type in 3412,96. That's your payment. Compute PV. There we go. Okay. Alright, so I'm not too sure what's going wrong. You just need to be careful when you type things into the calculator. Well, I mean, it's literally as is. And then obviously if you've got a deposit, you can add that to your loan. Okay, so that means I can finance a car that's worth 174,999. Okay, 18. S restaurant borrows 100 for 5 years. Okay, so PV equals 100. N equals 5 years.
Which is 60 months again.
Well, we don't know if it's months yet. Let's carry on reading. The bank charges interest at 12% compounded monthly. Okay, fine. Now we know it's months. So I12 equals 12% divided by 12. Okay, N is now going to be 60 months. Okay, and what is the equal monthly repayment of sea salt to the bank? Okay, so solve for PMT. Okay, that's it. Right, so PMT brackets rate 0.12 divided by 12. N 60. PV 100,000.
Yeah.
There's the answer 2224,44, option 4. Okay. Alright, 19 more TVM. Okay, family T borrows 50. PV equals 50. From the employer to fix the roof. They agree on an interest rate of 10% per annum compounded quarterly. That's I4. I4 is the quarterly rates. I4 equals 10% divided by 4. The loan has to be repaid in 2 years. How many quarters in a year? 4. 2 years, 8 quarters. So N equals 2 times 4, which is 8 quarters. Okay, considering the amortization schedule, the interest due at the end of the first 6 months. First 6 months is how many quarters?
6 times 4, 24.
No, first 6 months is how many quarters?
2 times 6, 12.
No. How many quarters in 6 months?
There's 2 quarters.
Yes.
6 months.
Very good. 2 quarters. But how do I get that? Well, how long is each quarter?
4 months.
No. A quarter is not 4 months.
Oh, 3 months, sorry.
Yeah,
3 months.
a quarter is every 3 months.
Yeah.
3 months, 3 months, 3 months, 3 months, 4 of them in the year. Okay, so every 3 months is 1 quarter. So in 6 months I'll have 2. Okay. Alright, so I need T2 basically. T2 question mark. That's basically what I'm working out. Okay, so step number 1. Okay, this is amort again. Alright, so obviously the first step is to get what? The payment. Okay, so solve for PMT. So let's see what we get. You should have gotten. Okay, the rate is 10, 0.10 divided by 4. The N is 2 years with 4 quarters, 8. The PV is 50,000. Okay, gives me that. 6973.37. Okay, what is that? That's the payment. That's not the interest due at the end of the first 6 months. Right, now use amort to get interest at T2. Right, so that we need to do on your calculator. So, master clear, reset everything, always. Okay, now what do? I first get the payment. So, 50,000 is your PV. Your I is 10 divided by 4, which is 2.5. Okay, your N is 8. Compute payment. Right, I get that. 6973.37, which is correct. Okay, then I want amort at T2. So, amort, change this to 2. Go down, change this to 2, and then scroll. That's balance, that's principal, that's interest. There we go. Right, interest is 0.0692. Right, so it's just using the calculator. There were quite a few, looks like it, in this paper. Look at amortization. Okay, question 20 and 21. Based on the following information below, the quantities and price of 4 items used by a company from that year to that year. Okay, this is probably indexes. Yes. Okay, so question 20 says, calculate the Lasperus price index for 2014 with 2012 as the base year. So 14 and 12 is important, round it to 2 decimals, so Lasperus. Okay, so I need a formula sheet. I'm just going to open up another past paper. Let's open up this one. Doesn't matter which one, they all have the same past, they all have, actually it's here, but it's fine, we'll use this one. Page what, 19, 20, somewhere around there.
20.
Last page. No.
19, sorry.
It's fine. Ooh, wrong button. Yes, okay, there we go. Okay, so where is Lasperus?
PL.
Okay, because I'm looking for a price index, right?
Yes.
That's what they said in the question, this one. Yeah, calculate the Lasperus price index. So you take this, copy, paste that. Okay, so question 20 requires me to use that formula. I need to write down these values. 2012, 2014. Okay, I'm also going to need this. Price, so that'll be P0, and this will be Q0. This will be Pn, and it'll be Qn. Does that make sense?
Yeah.
Okay, so 2012, quantity was 30. Price was 900. Price here was 1930. Quantity here was 15. Price here was 1650. Quantity here was 6. For D,
Price is 1200.
Hold on. Which item are we looking at?
2012.
Okay, we're not looking at a specific item, we're just looking at this prices.
Yes.
Okay, because they said item A, B, C, D here, so that's very unusual. It should have been one item, do you agree?
Yes.
With different prices. Yeah, it seems a bit weird having 4 different items, because then you would have had to have had 4 different prices. Yeah, so that's a bit odd. Okay, but anyway, let's see what we get. 25. Alright, and then this is 2014. So 2014, I had 32 as the quantity, with 1110. Okay, then I had 25 here, I had 8 there, and I had 30. Here I've got 2,500, 1,800, 1379. Okay, so that's what I've got. What does Lasperus say I must do? Lasperus says I need to sum up the Pn times the Q0. There's the Pn, and there's the Q0. Alright, so Pn Q0 is going to be this times that for all of them. This times that. Okay, and then do that for all of them, and then sum up. Alright, so that's my numerator. Now I need P0 times Q0. I need those two. Okay, so P0, Q0. This times that for all of them. Then sum up. This is the denominator. Okay, so now Lasperus here, P bracket L equals that divided by this times 100. Okay, 121.10. Perfect. Option 4. Okay, make sense? Right, so you're just taking the formula and you're drawing this out. I wouldn't redraw this. In the exam, I would have just written down, this is what I would have done. P-O, what is the one? P-O-Q-O, and I wanted P-N-Q-O. P-N-Q-O. And then I would have just literally have multiplied. So this would have been the N, no, that would have been the O, and that would have been the N. Okay, and then I would just have taken, so PN, price PN, so PN would have been this price, okay, times Q0, which would have been quantity there. Okay, and then I would have taken this times that, this times that, this times that, and then I would have written those answers there. Okay, and then sum up. Okay, to avoid having to waste time redrawing this in the exam. Okay, and then I would also, then for the other one, this is P0, Q0. Then I would have taken, where is P0? This is 0. Okay, that's N. So P0 is there, and Q0 is there. So I would have taken those two. Okay. And then I would just written answer, 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 sum up. Okay, so I would have done it on the actual question paper. I wouldn't have redrawn this. I'm just redrawing it now so you can see the step by step.
Yeah.
Okay. Alright, question 21. Calculate the Paschke index. Okay, for 2014 with 2012 as the basis. So it's exactly the same in terms of table, but I'm looking at Paschke. Okay, so go back. Paschke is which one? This one.
The PP it is.
Yeah, the PP. Okay. Paste. And then solve. Alright, so what does this want? PNQN, P0QN. P0QN. Do I have P0QN? No, I don't. Okay, so I need to do all of that again. Alright, so I'm just going to copy all of these values. Copy. Paste values. Alright, so there's the table. Alright, so now PN, QN. Okay, so PN, QN, PN, QN. That's it. This times that for all of it. Then sum up. Alright, then we want P0QN. P0QN. Alright, so P0 and QN. So this times that, okay, gives me that. And then I'm going to do that for all of them. Okay. Sum up. There we go. Alright, so numerator, which is that, over denominator, which is that. So PP is this divided by that times 100. Okay, 2181. 2118, sorry, not 81. Oh, it's 81. It is 81. Okay, there might have been a typo here in the question then. Correct, round off to 2 decimal places. 2 decimal places will be 81, yeah. So there might have been errata. I think they might have written this as 21,18. It should have been 21,81.
Yeah, but
okay.
Then it is none of the above.
It's none of the above, based on these options, yes. Okay, so based on the options, 21,81 is not an option. None of the above. Okay. Right, so those actually aren't too bad. Just use the formula, right? Okay. Right, the next one. Assume that the year 2014 consumer price index was that. Okay, so 2014 CPI was 102,7 in Feb, and so that was Feb. and then November. November was how much?
110.5.
Yes, okay, 110.5. So obviously prices have gone up. Right, an employee's wage was 20,000 in Feb. The wage was 20,000 in Feb. And the wage was 22,145 in November. This actually looks like a repeat question. It looks very familiar. Okay, it could have been a repeat question. I think we did one similar, or even exactly the same. Right, in relation to the value of the rand in November, his wage has increased by what? Okay, so do you agree I need to look at this in terms of increase? Okay, so how much has inflation changed? Right, so in order to work that out, what am I going to do? Okay, end minus start, close brackets, divided by start. That will give you the percentage times 100. Okay, so equals brackets. Okay, let's do it this way. Brackets. 110.5 minus 102.7, close brackets, divided by 102.7. Okay, equals that, times 100 to get a percentage. Okay, it gives me 7.59%. Okay, that's the increase. Alright, so do you agree if his wage was 20,000 in Feb, comma, with inflation, comma, his wage today should be, okay, let's see what it should be. Okay, so what should it be? Well, it's going to be the 20,000, okay, times 1 plus the rate of inflation. Okay, 1 plus inflation. Right, so that's 20,000 times brackets 1 plus 0.757594937 dot close brackets. Okay, equals an amount. Okay, so 20,000 times open brackets 1 plus this divided by 100 close brackets gives me that. Okay, so that's what his wage should be. Okay, so is his wage more or less?
It's more.
Yes. Okay, so in terms of inflation, right, he earned 20,000 in Feb. Okay, if we add 7.5% in November, that 20,000 should be worth 21,518. He's getting paid more in November than what his time value of money rate was or salary was. Okay, so the difference is this minus that gives me 626. So yeah, none of the above again. It's not there. 626.
Well, I got a different answer and I still get option 5.
Okay, that's good. Alright, so that's
but
fine.
That was just pure luck.
Okay, so yeah, none of the above. Okay, not an option. Yeah, the difference. That's the time value of money. So in relation to the value of the rand in November, okay, in November, see in November, right, his wage it would have been increased by 626,01 rand. Okay.
I got 67.
67, that's close enough. Maybe you just use rounding. Possibly. Okay.
No, I used a different formula. Oh. You say 1 plus inflation, I said 1 times inflation.
Oh, okay, 1 times. It should be 1 plus, yeah, because you're adding inflation. I'm adding 7%.
Yeah, I know that.
Okay.
Now.
Okay, 23. Alright, so 23 says, an inspector visits a large company to check its vehicles. The company has the following vehicles. 5 large load vehicles. Okay, so 5 large, 30 lights, 25 cars.
130 lights.
Is a 130, sorry, 130. Okay, the inspector decides to take a sample of 20% of all the vehicles. Okay, so sample 20%. 20%. Okay, so if I'm sampling 20% of all the vehicles, each type of vehicle is to be represented in the sample. Therefore, he will use the stratified random sampling technique. Okay, the number of light bands that should be inspected is, okay, so go to your textbook. We need to remember what stratified random sampling is. Stratified random sampling. Okay, that's
data collection.
No, yeah, really, yeah, sampling is there. Types of sampling, page 64. Okay, stratified random sampling, what is it? Just read it there. Random sampling requires no prior, just read that whole thing.
Okay, simple random sampling requires no prior knowledge of the population and can therefore be done with relatively little effort. It can, however, happen that all the elements drawn for the sample are nearly homogeneous.
That means the same, yeah, alike.
Okay. This may cause the conclusion about the population to be biased. If, however, you have prior information about the population, you can rule out this problem to some degree and consider more correct information about the population by making use of stratified random sampling. The population is divided into mutually exclusive sets or strats. This means that the specific element may belong to one group or stratum only. The strata must be chosen in such a way that there will be large differences between the strata, but small differences between the elements within the same stratum. Now, simple random samples are taken from each stratum. Often the number of elements taken from each stratum is proportional to the size of that stratum. Okay,
so that's the theory. Okay, now we need to look at this, the example. Okay, so this is what? The stratum. Okay, 1 to 5. Stratified random sampling. This is looking at stratified random sampling. That's correct. Okay, so in this, the stratum was divided into 3 different sections. Okay, so there's the sections 1, 2, and 3. There's the frequency, which we've got. So how do we draw a sample? The number of items that must be drawn from stratum 3 is, okay, so from stratum 3 is that, so 5 over 30. Okay, alright, so 12 was what?
No, it's like stratum 1 is 15. Because
yes, I get that. So that's the frequency, the number of observations. So to draw a proportion size, a sample size of 12, 12 would be, so what are we looking at? We're looking at 20% of all the vehicles. Okay, so what is 20% of all the vehicles? 20% of the total, okay, is 20%, 0.020 times brackets 5 plus 130 plus 25, close brackets. Does that make sense?
Yeah.
Okay. Okay, so 20% of all those vehicles is 32. 32 is the 20% of the total. Okay, so that means to draw a proportional sample size of 12. So 12 means the amount that you're taking from the sample. Okay, and then we've got this. So from stratum 1 would be 15 over 30, so it'll be the frequency. So I should draw it like this. Stratum 1, stratum 2, stratum 3. Okay. Alright, and then I've obviously got cars or observations frequency. Okay, so frequency for the one was 5, then 130, then 25. Okay, the total is obviously 160. Okay, so what am I looking at? The number of light vans. Okay, so light vans equals. Okay, so if I'm drawing a proportion size of 12, so how much am I drawing? I'm drawing a proportion size of 32. Okay, from 32 will be from the 15 over the 30, which will be from the 30 over the 160. Okay, so I'm just following the rules in your textbook. Okay, so 32 times 130 divided by 160 equals 26. Option 4. Okay, that's a tricky one. That's a tough one.
Okay, I'll do it in another way, and it was a lot easier doing it my way, but I'm not sure if it's right. So I say 20% of 5 is 1, 20% of 130 is 26, and 20%
it still
of 25
works.
is 5. So, and then I still got to option 4 because
okay, so well done.
Yeah, because I said the 20% of the light vehicles.
Okay, that still worked. But I'm just following the textbook. So the textbook gave a very complicated way of describing the
thing is, when I used the textbook, I couldn't understand it. So I just did it my way.
Yes, it worked. So good, your way worked. Okay. Alright, 24. This is stats now. Assume that a data set of 50 observations, the largest value is that, the smallest value is that. If there are 8 classes, the width of the class intervals is, okay. So this we actually need to draw while we need to interpret. Okay, so 50 observations. Okay, largest value, so the highest, the high and the low. Okay, the high was 108, the low was 68. Okay, if there are 8 classes, okay, so 8 classes. Okay, so we're looking at observations in terms of I'm assuming this 108 and 68 is the time. Class intervals. The width of the class intervals. Because they're asking for width. So width to me means how long the classes are. I don't know if that makes sense. Does it make sense?
No, it didn't make sense when I tried to do it. So.
Okay, so to me, the width of the class, so right now I've been given the number of observations, which is basically n. Okay, I've been given the highest and the lowest points. Okay, so if I've got the highest and the lowest point, I can work out the average. Okay, so the average would be 108 plus 68 divided by 2. Okay, so this plus that divided by 2 gives you 88. Okay, and 88 is what? The average. Okay, and then they want 8 classes. So they said if there are 8 classes, the width of the class intervals is. I don't think the 8 classes would have had any relevance on the width of the classes because you would just multiply everything by 8 because it's still an average. So looking at that, I've got n and I've got n observations. So out of 50 classes that I've observed, I can see that there's a high of that and a low of that. On average, 88 would be the average for the 50 observations. So the width of the class intervals, maybe the 8 classes means divide by 8. But then you won't get an answer. 88 divided by 8 is 11. There's no 11 there. The width. Let's just check if there's anything about width here. Is there index in this book?
Yes, right at the front.
On the front? Oh, no, but not this type of index, but it's fine. It's a contents page. Okay, let's just see if there's anything about time here, width. This is looking at observations, so data collection. So 61. Let's just see if there is anything here. Oh yeah, the mean dispersion. Okay, so let's go to 61. And just double check the theory to see if there's anything that speaks to this question. Here's data collection. Alright, there's samples, variables. That's types of sampling. We're not looking at types of sampling. We're looking at measuring width. So this would be a measure. There, decide on the number of intervals. This is range. Okay, there, range, min and max. There, determine the width of the interval. Okay, actually I need to use this formula. Alright, so we actually need to use this page. Okay, so C, page, what is that? Page 69. Bracket, very specific, calculation. Okay, so the formula for width. Width equals... width is not in terms of like, length times breadth. Yeah, that's something different. Width is something else here, which is R. R is what? This, the range. Okay, so range divided by number of intervals. Okay, so what is my range? My range would have been the difference between the highest and the lowest. So width equals brackets. The range is 108 minus 68. Close brackets divided by the number of intervals. How many intervals do we have?
8.
Okay. Gives us an answer. Gives you 5. Still none of the above. Okay. Option 5. Option 5. None of the above. Alright, so yeah, width is 5 according to the textbook.
I couldn't do it. I tried last night again and...
Yeah. Okay, you can see here in the textbook, range, they said, decide the number of intervals. Yeah, divide by 10. 10 would have been the, which in this example would have been the, where's the example? Where does it start?
Unless you need to divide it by 10. No, it doesn't say.
Oh, it's just a random figure. See, R is large, but any number between 5 and 8 is acceptable. Do not use fewer than 5. So, yeah, it's not a very good question, actually. Okay, but anyway, we're using what's in the textbook. I don't like that question because there's room for, how can I say?
Miscalculation.
Misinterpretation, actually.
Yeah.
Okay. Alright, last 5. 25 and 26 are based on the following information. Number of bicycles sold monthly by a bicycle seller in 2011 is as follows. Month and number. Great. What do they want? Okay, the median number of bicycles that were sold during 2011. So median means middle point. Okay, so to get the median, I need to order the data. Okay, so what's my smallest figure? Okay, let's just write down this. Ooh, 9, 10, 11, 12. Okay, so let's put them in order. What's the smallest figure? Smallest one you can see, I see 16. Then 18, 18. Please check if I'm right. 19.
Yes, 20.
21. Is there a 20? Oh, there is a 20. 20, then 21. 25. 24. Then 25. After 25, 30.
And then 33.
33.
36.
36. Last one, 45. Great, there's it. Okay, so what's my median? My median point would have been the middle point. So I've got 6 here and I've got 6 there. So the middle point would have been between those two. Okay, so median equals brackets 21 plus 24 divided by 2 equals. Okay, so brackets 21 plus 24 close brackets divided by 2 gives you 22.5. Option 3. Okay, 26 says the mean, round it off. Okay, so mean is average. That's easy. Question 26, you're just going to work out the average. Average equals total divided by the number. Does that make sense? Do you agree?
Okay.
So average.
Yeah.
Okay, so equals, sum up all of this divided by 12. 25.41. 25.41. 416. So 416, if I round up, it's 25.42, option 1. Okay. Okay, that's just an average, normal average. Add up everything, divide by the number. Okay. Makes sense?
Yeah, just did it wrong.
Yeah. Okay, 27 is theory. Standard deviation of a dataset is used to find the following. Okay, standard deviation, the dispersion around the median, no. The dispersion around the mean, yes. Relative variability between datasets, no. Average of the dataset, no. Okay, it's 2. Right, 28, okay, we've got a whiskers thing here. Box and whiskers diagram given below. Okay, where A, so where's A? Here's A. Okay, so let's write it down. A is 75, B is 55, C is 45, D is 35, E is 20. Okay, without making any calculations, determine the quartile deviation for the data. The correct answer is, okay, so quartile deviation. We need to go to box and whiskers in the textbook and just to see how we interpret this stuff. Okay, so where's our box and whiskers? Here's our box and whiskers. Okay, so quartile, so largest value is there, quartile 3 is there, quartile 2 is there, quartile 1 is in, smallest value is there. So determine the quartile deviation for the data. Quartile deviation, where is quartile deviation? Do they give that to you? No, they don't. So deviation would be the difference between the two. Quartile deviation, is there anything about quartile deviation here? There, quartile deviation. Okay, so in study unit 6.3, the median of that value, okay, so we divide into those parts. Okay, the first quartile is that, which is the end of the 25%. The second quartile is the next 25%, and then the third quartile is the next 25%. The second quartile. So what is the quartile deviation then? Doesn't say what it is. Here.
Okay.
The middle 50% of the data lies between Q1 and Q3. The measure DQD equals Q1 minus Q1, Q3 minus Q1 over 2. Okay, there's it. Alright, so in the textbook, quartile deviation, this is 28, eh?
Yes.
Okay, so QD, brackets from page, say from page 84, equals Q3 minus Q1, close brackets, divide by 2. Okay, so if I look at my whiskers graph, Q3 is the B, so 55, minus Q1 is the D, 35, divided by 2. Okay, that gives you 10. Without making any calculations, determine the quartile deviation from the data. The correct answer is none of the above again. Wow, so many of these ones. Option 5. Okay, see page 84 in the textbook. Alright, so yeah, that's that one. Yeah, it's really bad if they always do none of the above. It's not really good. It's better just to give an answer.
Yeah.
It's not the best of options. Okay, but it looks like they like it. Okay. Alright, so question 29. Well, only in this paper though. Other papers not the case. Okay. Assume the company can sell as many units of its product and can manufacture in a month at that. Okay, so cost would be that. Do you agree? Oh, that's the selling price actually. I'm reading it wrong. Okay, so selling price 316,26. The company has to pay fixed costs, FC. Fixed costs of 4216,80. Plus a cost of that for each unit, and then variable cost, VC equals 245,98 per unit. Okay, this is also per unit. Right, what is the profit if it produces 200 units in a month? So we first need to work out the profits. Okay, so profit function equals, how do I get profit? Total revenue minus total costs. Okay, so the profit function is going to be, total revenue is price times quantity. Okay, so price times quantity, what is my price? 316,26 times quantity minus cost, total cost. So I've got variable cost 245,98 times quantity, close brackets, minus fixed costs, minus 4216,80. Okay, so total cost would have been fixed and variable. Those are my total costs, fixed and variable. Okay, so now I need to substitute in. So profit if I produce 200 units, so times 200 here and times 200 there. There's the profit. Okay, profit equals 9839.20, option 1. Okay, so you're just getting the profit function, that's the key. How do I get profit? Simple. Take everything, all your revenue, minus all your costs. Okay, so how do I work out revenue? Price times quantity. That's my price times the quantity, which is 200 in this example. Okay, how do I get the total cost? Well, costs have fixed and variable. Okay, so fixed costs, 4,216 Rand 80 cents. Variable cost, 245 per unit. Okay. Alright, so total revenue minus total costs. Alright, question 3. Let PX be the profit if X units are sold and manufactured in a month. What is the marginal profit? Okay, so marginal means get the derivative. Okay, so profit function is this. Profit function equals 316,26x minus 245,98x minus 4216,80. That's the profit function. Okay, we need to simplify the profit function. Okay, so what is 316 minus 245.98? Gives me 70.28. So profit function is actually 70,28x minus 4,216. Alright, then get the derivative. So marginal profit equals the derivative of profit. Okay, so if I derive that, I drop the constant and I have that as the derivative. So it'll be 70,28. That would be it. 70.28, option 4.